Okay, so today we're going to look at a forensics analysis of glass and understand why and how you can look at glass and find evidence in that way. We kind of got to understand a little bit about the actual properties of glass, so that's what we're going to talk about today. So there are some different types of properties. We kind of tend to look at optical versus non-optical. So optical properties include color and refractive index. Non-optical properties are like surface wear, striations. This is like just microscopic like lines in the glass, how thick it is, if there's a surface film. Sometimes you look at dirt, the hardness of it, and then its density as well. And then you can also sometimes look at chemical properties, additives or trace elements. This is stuff that they may add to glass. For example, if they want to add a little color to it, they may add some additives to make it like blue or pink or something like that, green. So the goals in examining glass evidence include determining the type of glass at the scene, to determine how the glass was fractured or broken, use physical characteristics to classify it, and then individualize it to a source. So you're going to look at basically what kind of glass you got there, how did somebody break it, what kind of glass is it, and then where did it come from. So what is glass? Glass is typically made from a fusion of sand, soda, and lime. Sometimes, especially if lightning strikes a beach area, you can actually find glass at the beach. I know there's people that actually make glass sculptures by putting lightning rods in sand and wait for lightning to strike them. The lightning will heat up the sand like instantly, and the electrical properties of it will actually form glass. So some physical properties of glass is that it's hard, elastic, brittle, does not conduct electricity, different types of density and refractive index. So what types of glass are there? I mean, glass is used for everything. And you don't need to take notes on this. This is not something I'm going to ask you, but there's different types of glass out there. Colored glass is the one thing that you will see when they add different types of metals or iron or sulfur. This can change the color of the glass. So how do glass windows break? Each force causes a deformation that may leave a visible mark or fracture the glass. This can be used to determine the direction and the amount of force. Glass acts initially as an elastic surface, and it does bend when force is applied. But when the force increases the strength of the glass or its tensile strength, then it will crack, as you can see in this diagram below. So there's different types of ways that glass can break, and this can show you perhaps if there's different, let's just look at bullet holes, for example. You could see if there's multiple bullet holes, you'll be able to tell which one breaks first, that kind of thing. So radial cracks, they form first, and they're spread in short segments on the side opposite the force. So if you follow my cursor, these are radial cracks. Concentric cracks come later from continuing pressure on the same side as a force is applied. These are these circular ones. So as you can see in the different types of glass, there's different ways that it can break depending on the type of glass. Regular glass would leave a hole. Laminated glass won't leave a hole, but it will leave a fracture. And then toughened glass, this is your tempered glass, like a lot of windshields are made of this. It won't shatter as much as it will just have completely crack, but it won't actually break off. Fractures by projectiles, again going back to bullets. As the bullet's velocity increases, the central hole becomes smaller, cracking patterns become simpler, and the exit hole becomes wider than the entrance hole. So one of the ways that you can see, did it come from the inside or the outside, the exit hole is going to be bigger than the entrance hole. So if you're looking at, say, for example, in a car, the exit hole is bigger on the outside of the car, the bullet hole is bigger on the outside of the car, that means the bullet was fired from the inside of the car. So again, exit side is wider than the entry side. Stress lines on the glass edge of a radial cracks form a right angle on the reverse side from the force. Stress line on the glass edge of concentric cracks form a right angle on the same side as the force. So this will let you know where the force came from as well. The sequence of impacts can be determined since crack propagation is stopped by earlier cracks. So basically, if you look here, it's pretty obvious that these cracks were stopped by these lines. So therefore, which one do you think came first? Well, it would be this one because these were stopped by. So we know that this bullet hole occurred first. Now, same for this one. Can you guys figure out if it was A or B? Okay, so B would have occurred first. And sometimes examiners can fit together a couple pieces of glass or broken from the same object. And because glass is amorphous, no two glass objects will break the same way. When you're collecting glass samples, you need to be packaged in boxes so that they won't break any further. Each item should be individually wrapped. If there is a remote possibility that glass fragments can be pieced together later on, you should try and collect every piece of glass fragment. And then you should always take your control sample. So when we go back to surface striations and markings, this can help us realize if there's pieces missing and how they fit together when you're putting them together. And they can also be used to individualize your evidence as well, because you can match up pieces of glass if they have the same striations. But if you get a piece of glass in there that looks the striations are completely different, then it may not have come from that original source. So let's look at density. Density can be measured by directly determining the mass and volume. We use this by displacement, as you can see up here, if you guys remember from chemistry. Comparison by flotation or density gradient column, but we're not going to go into that to gradient column. And we're going to skip that. So why measure refractive index? Well, refractive index is the ratio of the velocity of light in a vacuum to the velocity of light in any other medium. So this basically, if you remember, refractive index is like example, where you can put like a pencil in water and it looks like it's bent, but it's not. But the reason why we look at that is because it varies with small changes in composition or by how it's manufactured. So that allows us to individualize the source, find out where it came from. Kind of going back to my pencil theory there. Skipping. And we're going to skip. Okay, so what you do need to know is glass has a higher refractive index when it has a white line on the inside of the piece. It has a lower refractive index if there is no white line. And as you can see, there's kind of like a white line that goes on the outside here. Here, there is not. The FBI has compiled a density and refractive index from glass all around the world. Now they can individualize about 1,400 glass specimens. So we can do a chemical analysis of glass. So basically under UV radiation, it will exhibit a glow. And this is due to different types of heavy metals that are either inside it or on a coating. And we are finished. Make sure you get that, if you have not turned in your answers for the worksheet from Friday, make sure you get that done today because that is due today. So it was the first 20 questions.